The brain on hormonal contraceptive. Depression is one of the most common mental illnesses in the modern world, with over 3 million cases diagnosed annually in just the United States. Whether passed down hereditarily or medically induced, the effects are devastating for many individuals. Recently, there has been a discussion among the medical community about the link between depression and hormonal birth control. Many scientists believe that because the link has not been established experimentally, it cannot be concluded that there is a correlation between the two. The common justification is that the sudden depression experienced by some hormonal contraceptive users is simply situational or seasonal. In the past 2 years, researchers have identified kynureninic acid as a possible medical explanation for induced depression by hormonal birth control. Kynureninic acid concentration, along with estradiol concentration, appeared lower in females who took oral contraceptives. Researchers decided that the pathway was through the interaction between the immune system, which is stronger in females, and the sex hormones. Immune cells such as B lymphocytes, T lymphocytes, and dendritic cells have estrogen receptors, so their ability to attract estrogen may account for the decreased levels of kynureninic acid throughout the body. This means that someone's brain on oral contraceptive will have less neuroprotective metabolites working against inflammation and swelling in the brain. It also means that their brain will effectively increase its metabolic activity towards the neurotoxic portion. This aspect of the kynurenine pathway decreases the amount of tryptophan, an amino acid that prevents symptoms of depression and anxiety. The following proposed mechanism, however, explores a theoretical pathway that differs from that of kynureninic acid. Let's take a look. Estrogen, one of the main hormones in contraceptives, has two polar ends. This allows the molecule to create hydrogen bonds with the nitrogen atoms of dopamine and other polar neurotransmitters, such as serotonin and some types of endorphins. Typically, the neurotransmitters would cross the synaptic cleft and bind to their respective postsynaptic receptors, triggering G protein cascades or other secondary messenger responses to elicit happiness. But the probability of forming a hydrogen bond with the unusually large amount of estrogen overrides this. That means the neurotransmitter molecule never makes it to the postsynaptic cell. Although this may only happen to a few molecules per synapse, the accumulation of molecules that are not producing postsynaptic excitatory potentials leads to major or minor depression. This pathway reveals why large amounts of estrogen have the ability to become harmful in the body by contributing to depression and anxiety, especially in women with naturally high estrogen to begin with. The script, drawing, and video production was by yours truly, Anna Carly. Information in part was from Timothy Meyer and his team of researchers from Brain Behavior and Immunity, Volume 67, pages 59 through 64, copyright of 2017.